Planet Earth. Roughly 71% of the world's surface is covered in water. There are an estimated 7.45 billion people living on Earth today. Since 2010, 80% of the people will live within 60 miles of the coast and its waterways and rivers. 3/4 of the world's megacities are by the sea, and with an ever-growing population, the demand for energy has never been greater. Project MWED is a senior design group from Florida Institute of Technology that, using the skills of our team of 4, we have developed an alternative to conventional electricity producing methods. Most of the world's electricity today comes from the combustion of coal, oil, and gas. Our team has developed a wave energy device that uses Faraday's induction to generate a current. The acronym MWED stands for Magnetic Wave Energy Device. To demonstrate our concept, these CAD designs illustrate how the device works. The basic principle of our device is nothing more than a piston design where a magnet is attached to the end of a piston shaft, of which will oscillate through a copper coil, hence using Faraday's induction. Where our device stands out is at the two ends of the cylindrical shell housing, where 2 magnets will repel the middle magnet attached to the shaft and therefore generate oscillations. In this model, we can get a clear picture of where the middle magnet attached to the shaft surpasses the copper coil. We believe that with this simple design, it will be able to lower production costs and therefore make this product widely available to low-income regions of the world in coastal communities that often find themselves off the electric grid.
This is our top component of our device. This is a top view, which has two discs where our magnetic coil will be attached between the 2 discs. This is the portion where our electronics will be installed, and these are the 4 screws which will be mounted just below the docks. The screws here. This will be used to just mount below the docks. And the magnet inside this cylinder will oscillate between the coils, and it will generate some energy.
Discuss the software and what exactly you do.
This component has been designed in SolidWorks 2012 software, and this is a very efficient software, and it is a very user-friendly software. And from this software which has been designed, it will be transferred to the ANSYS software, where the analysis will be conducted, and we will be able to analyze all the static analysis, dynamic analysis, CFD, etc., so that we can get a good force analysis, and we can decide the design accordingly.
So as with any project idea, we began with a rough prototype. In this video, we can see that Faraday's induction indeed does work the way we had planned for this device. The next steps are the orientation of our magnets. With extreme caution, we aligned each magnet in its correct orientation. This step was pretty nerve-wracking, since the crush force of one of these magnets can reach up to 200 pounds. Now, with a working idea and a prototype that could be attached to a dock or pier setting, such as this one along Key West, we still had a major hurdle. How will we be able to expose this product to benefit the upper economic coastal niche, those who have the pockets to afford electricity on their luxurious homes and yachts? What we came up with was its practicality due to its 3-foot size and the ability to offset their carbon footprint, which has been a trend for the wealthy wanting to give back to the environment. With this idea, we were invited to present our concept at the 2016 and 2017 NASA ESA Workshop for Environmental and Sustainability as seen here. Our project was also selected for an energy infrastructure competition.
Good morning. I would like to welcome everybody back to the 2017 Cuba Infrastructure Scholarship Competition. This team is coming from Florida Institute of Technology, MWED, Magnetic Wave Energy System Device. In second place, and this is where the race got really tight, in second place, I would like to welcome the team from Florida Institute of Technology.
Congratulations. Great job, guys.
I could hear some preemptive celebration in the back.
It was the first time our school was represented in this competition. So now, as our school project comes to a completion, we were left to construct a model that worked with all the aspects that were advertised. In these clips, we took the first initial trials of our completed prototype, and with readings of 1.5 to 3 volts, we were looking good. Our project is far from over. We plan on opening a business, and with a little luck and determination, we believe a device could contribute to our species' isolation of the dependence of fossil fuels, one oscillation at a time.